So in this video, I'm going to discuss describing motions with diagrams. So if you turn to your green packet, page 12, you should find a worksheet, and we're going to work through all of this. So it has the instructions that motion can be described using words, diagrams, numerical information, equations, and graphs. So using diagrams to describe the motion of objects involves depicting the location or position of an object at regular time intervals. So we're going to be paying attention to these little pictures of vehicles as if they were moving along a road, and we're taking snapshots at regular intervals. So number one, motion diagrams for an amusement park ride are shown. The diagrams indicate the positions of the car at regular time intervals. For each of these diagrams, indicate whether the car is accelerating or moving with constant velocity. If accelerating, indicate the direction right or left of the acceleration and support your answer with reasoning. So for accelerating, remember we're paying attention to if it's speeding up or slowing down. Both of those we are referring to as acceleration. Since they're traveling in a straight line, you really don't have the third possibility of changing directions. So if we take a look at the little pictures, it looks like they're all heading to the right. That's my best guess looking at those little pictures and the people. So if they're speeding up, that means the direction of the acceleration will also be to the right. And if they're slowing down, the direction of their acceleration would be to the left. And if they are traveling at constant velocity, there is no acceleration. So let's take a look at the first one. So if you look at this first one, these cars look pretty evenly spaced. So I would say they look like they are traveling at a constant velocity. So there is no acceleration. So since there's no acceleration, there's no direction. If you look at B, the first time interval, the car travels a little bit, and then it travels a little bit more and more and more and more. So that looks to me like it is speeding up because the distance between each of these car positions is increasing as time goes on. So that would say that it's accelerating, and the direction of acceleration is the same as the direction of motion, which is to the right. Letter C. This looks familiar. We've got these cars, they're spaced at even intervals, which indicates it's traveling at constant velocity. So that means it's not accelerating, and so there's no direction of acceleration. And letter D, we have this car, and it's fairly close together here, and then it gets a little farther and farther and farther. So that looks like it's speeding up. So it is definitely accelerating. And since it's speeding up, the direction of the acceleration is to the right, the same as the direction of motion. So in letter E, the car is fairly spaced out, and then it's doesn't travel quite as far, doesn't travel quite as far, doesn't travel quite as far, and hardly travels here at all at the end. So this one is slowing down. This one is still accelerating, and this time the direction of the acceleration is to the left, in the opposite direction in that it is from that is what is moving. Then number 2, suppose that in diagram D above, the cars were moving to the left and traveling backwards. What would be the direction of the acceleration? Explain your answer fully. So if we just take part D here and say that cars were traveling to the left. So they're fairly far spaced out here. It's a little closer, it's a little closer, it's a little closer. So if it was traveling this direction, it would look like it was slowing down. So if it was slowing down, that would mean the direction of traveling is to the left, but the acceleration vector would be to the right. So, I'll show a copy of the answer key here. If you need to pause the video and kind of go through that, go ahead. But I want to note that the answer down here on number 2 is incorrect, okay? What I just talked through was correct. If it was letter D and they were moving to the left, the acceleration vector would be in the opposite direction. The answer key here is incorrect, so don't copy the wrong answer. So now we're going to do pretty much the same thing, but now instead of having little pictures of cars, we're going to have little oil drops. So this is kind of like what you've already seen. So you're assuming a car is dripping oil, or maybe dripping water when it's hot in the summer and you have the AC on in the vehicle. And it's leaving these drips every second or some regular time interval. So let's take a look at 3 and see what we've got. So based on the oil drop pattern for car A and car B, which of the following statements are true? Circle all that apply. So A, do both cars have constant velocity? Are each of these evenly spaced? No. B, both cars have an accelerated motion. Well, yeah, they're not evenly spaced and they're both speeding up. So it looks like they are both accelerated. So B is definitely an option. C, car A is accelerating, car B is not. Well, we know that's not true. D, car B is accelerating, car A is not, and that's not true. E, car A has a greater acceleration than car B. Well, let's take a look at that. So what I want you to do is I want you to go over and I want you to count from the left and I want you to circle the 5th dot. I'm picking number 5 at random. Okay, so 1, 2, 3, 4, 5. That would be this one. Then I want you to circle the 5th dot here. 1, 2, 3, 4, 5. You notice there's a difference between those two. It's hard to see unless you circle them, which is why I asked you to do that. So which one is accelerating more, faster than the other? And once you circle them, you can tell that car A has a greater acceleration than car B. Okay. Number 4. Oh, sorry, F. Car B has a greater acceleration than car A. That's obviously false because we already said that E is correct. Number 4, an object is moving from right to left. Its motion is represented by the oil drop diagram below. This object has a blank velocity and a blank acceleration. Okay, so it's moving from right to left. That means it has a leftward velocity and we can know that by this arrow here. And if we think about something moving to the left and we look at how the drops are, they're farther apart here at the beginning than they are at the end, which tells us that it is slowing down. If it's slowing down, that means the direction of the acceleration vector is the opposite the direction of motion, which means it would be rightward. So our answer here would be left and leftward velocity, rightward acceleration. So that would be C. Then number 5. Renata's oil's car has an oil leak and leaves a trace of oil drops on the streets as she drives through Glenview. A study of Glenview's streets reveals the following traces. Match the trace with the verbal descriptions given below. For each match, verify your reasoning. So if we just kind of take a look at these, let's look at the verbal description. So the first one says, Renata was driving with a slow, constant speed, decelerated to rest, remained at rest for 30 seconds, then drove very slowly at a constant speed. So which one of these looks like they start with a slow, constant speed, decelerates to rest and stays there, and then still drives very slowly at a constant speed? Well, I'd say A and C both have this point where they're stopping because you're getting like a pile of oil. But as far as being slow, looks like I would say C is the one where it's mostly slow. So here I would say this is a constant speed. This is a constant speed. They decelerated right here and they stayed at rest right in that area where the oil pulls up. Number 2, Renata rapidly decelerated from a high speed to a rest position, then slowly accelerated to moderate speed. Okay, so that looks more like what we've got here. because this one also goes to a rest position. So they decelerate, it gets closer and closer together. They sat at rest, and then they accelerated to a moderate speed here. So it looks like number 2 matches diagram A. So hopefully that means the last one is letter B, but let's just verify it. Renata was driving at a moderate speed and slowly accelerated. Well, she's driving here at a slow, moderate speed, and then they start getting farther apart. So that definitely does match. So here is the answer key. And again, pause it if you need to copy down the answers and replay any part that you don't quite understand. So what I'm going to have you do today is something online. So you're going to go to this physics classroom website, and you're going to do a concept builder there. So there is an interactive there. And I normally do this in class, and it's normally a lot of fun. And I'm sorry that there's no really good way to do this right now. And also with you guys all being at different places in the chapter, it also makes it very hard. So the way this is going to work is you are going to go to the website, and it'll look like this. And you'll go into this name that motion. And what you're going to do is you're going to answer each of these questions, and you'll ultimately end up with a gold star here. You can kind of see this faded outline of the star here. Once you've answered all of these questions, you're going to take a screenshot of it to share it with me. You'll find these to be fairly easy. They are going to get a little bit more complex as you go, but this is really good practice for looking at these motions and recognizing which direction acceleration is going. If you have any issues with the website, there's a video here, there's additional notes, there's additional tutorials on here to help you if you get stuck. Okay, so that is one thing that you're going to do. So you're going to go to that website. You're going to see if you can identify all the motions. Once you have a gold star next to all of those, take a screenshot, submit that to Classroom. When you're done, you're going to be ready for the MOPAP KC5. And once you've done that concept builder, you're going to find KC5 pretty easy. So go ahead and work on all of that. And then I will be with you for the next video.